Hello everyone. In this video we will discuss the basic concepts of kinematics. The video is for students of O levels and A levels both because it actually includes those concepts that are part of O levels and A levels. The concepts which are part of AS will be separated by this video, and I'll upload that part in the next video. First concept is distance. The basic difference between the distance and the displacement is that the distance is the total length covered by the object irrespective of the direction in which it was traveled, or you can say that the distance is the total length of path taken by the object. As you can see that the distance is not dependent upon direction, so it is a scalar quantity and the unit of distance is meter. While displacement is the shortest distance between initial and the final position of the object in a specific direction, which means that the displacement is actually dependent upon direction and it is a vector quantity and its unit is meter. I have made two lines, and these are two positions A and B. A is the initial position of the object while B is the final position of the object. If object covers distance from A to B and uses the path which is of black line, so the length of this black line is actually distance, and you cannot specify its direction because it is not covered in a straight path, so you cannot specify its direction. While red line is actually indicating the shortest distance between the 2 points, and since it is in a straight line you can also specify its direction. As it's from A to B, I can specify its direction as due east. If you cover distance from A to B and you move back to position A from where you have started, the displacement will be 0 but the distance will not be 0. Now speed is distance covered per unit time. It means how much distance you have covered and how much time you took to cover that distance. If you take the ratio of these two physical quantities, you will get speed. Symbol of speed is V. Symbol of distance can be S or D divided by time taken, while average speed is total distance upon total time taken. SI unit is meters per second, and it is a scalar quantity because it is not dependent upon direction. Neither distance nor time has direction, so speed is a scalar quantity. Similarly, velocity is actually change in displacement per unit time. How much displacement you have changed and how much time you took to change that displacement, the ratio of these two physical quantities will be velocity. And since distance is measured in meters, time is in seconds, so SI unit for velocity is meters per second, and it is a vector quantity because it is dependent upon displacement. Average speed is total distance upon total time, so average velocity will be total displacement upon total time taken will be average velocity. If you sum up the total displacements and you divide it by the total time in which that displacements were made, the ratio will tell you the average velocity, as you have done in average speed as well. Now gradient. The concept of gradient is very important. Gradient is actually steepness, or you can say the angle by which a line is inclined with the x-axis. You have learned gradient as steepness or inclined or slope. The gradient of the horizontal line is 0 because it is not inclined with the x-axis, while the gradient of the vertical line is infinite. which means this is the maximum angle a line can make with the x-axis, and this will give the maximum gradient to that line, because if you increase the angle further, it will again become it will start to decline towards x-axis. So this is the maximum inclination a line may have with the x-axis, which is 90 degree. So remember always that horizontal line is actually having a zero gradient, while vertical line has the gradient which is infinite. The formula to find out gradient is y2 minus y1 upon x2 minus x1, where y and x are the, you can say, coordinates. Coordinate is actually x comma y, which points out the location of the point on the graph. So if you take two coordinates x1 y1 and x2 y2 on the line, you can find out the gradient of the line by y2 minus y1 and dividing it by x2 minus x1. This line is neither horizontal nor vertical, but this line is actually straight. So the gradient of this line will not be 0 and will not be infinite. It will more than 0 and less than infinite. So I can call it non-zero gradient. Since line is straight, so its gradient is constant, and since the value of y is increasing, so its gradient is positive. So this line has a gradient which is positive, non-zero and constant. Positive because y, the value of y is increasing, constant because the line is straight, and non-zero because greater than 0 and less than infinite, so it's non-zero. This line is straight, which means the gradient is constant, but the value of y is decreasing, so the gradient is negative, and the gradient is non-zero because it is not horizontal, neither vertical. Constant, non-zero, negative. Gradient of the dt graph is actually speed, or you can call it velocity. If d is distance and t is time, so it will give you speed. If d is displacement and t is time, so it will give you velocity. So let's discuss some dt graphs so that we have a greater idea how to analyze when there is graph given in a question. dt graphs, which means distance time or displacement time graphs. This graph has zero gradient. This graph has constant, non-zero and positive gradient. The gradient of straight line is always constant, right? Non-zero and constant. Gradient is increasing because the value of y is increasing at a greater rate as compared to time. Gradient is decreasing. You can also use the concept that the line is becoming vertical, that's why its gradient is increasing. The line is becoming horizontal, that's why its gradient is decreasing. Negative, constant and non-zero. Gradient is negative, decreasing because the value of y-axis is decreasing, and it's non-zero. Non-uniform because the line is not straight. The gradient is decreasing because the value of y-axis is decreasing, and it is negative. Okay. Now, if I apply the formula y2 minus y1 upon x2 minus x1 on this graph, I will see that I can apply the formula as d2 minus d1, because on y-axis it's not y, it's d. So d2 minus d1 divided by t2 minus t1 will be the gradient of this graph, and d2 minus d1 divided by t2 minus t1 is actually distance upon time or displacement upon time. So the gradient obtained from dt graph is actually speed or velocity. Now in this graph the gradient is 0, which means the speed is 0, or you can say the object is at rest because it is not changing its distance or displacement. The gradient is constant, non-zero and positive, which means speed is constant, speed is non-zero and speed is positive. Gradient is increasing, so speed is increasing, or you can say velocity is increasing. Gradient is decreasing, which means speed or velocity is decreasing. Gradient is negative, which means speed is negative, but you can see that speed is never negative, so you cannot call it speed, it is velocity. Negative velocity and a positive velocity, the difference between negative and positive velocity is actually, positive velocity is when the object is moving away, negative velocity is when the object is moving towards, and vice versa. Which means velocity is actually, the negative sign is actually indicating the direction, because in vectors neither -5 nor +5 will be of greater magnitude. Negative and positive just tells you the direction. If you say that the force is of 5 Newton and the other force is of -5 Newton, -5 Newton and 5 Newton, both forces are of equal magnitude but in opposite direction. Similarly, 10 meters per second and -10 meters per second is the same speed but in opposite directions. If positive 10 meters per second is actually the speed when the object is moving away, then the negative 10 meters per second will be for the object that is moving towards. The gradient is non-uniform and negative. You will write negative when the value of y is decreasing. As you can see in E, F and G graphs, the value of y is decreasing, so the gradient is negative. The gradient is constant because the line is straight. The gradient is not constant because the line is not straight in F and G. The gradient is increasing because the line is becoming vertical, right? So gradient is increasing. So you can write negative increasing velocity. The gradient is decreasing because the line is becoming horizontal. So you can call negative decreasing velocity, but non-uniform because the lines are not straight. These lines are you can say curved, so they have different gradients at different points. Now moving on to acceleration. Acceleration is actually change in velocity per unit time. In this definition, I have a question for you. Let's say an object is revolving in a circle with a constant speed. Is this object accelerating or not? The object is actually revolving in a circle. Its speed is constant. Since its direction is not constant, you will see that the velocity will not be constant, because velocity is actually a vector quantity. It changes with the change in direction. Since object has a constant speed but the direction is not constant, then we will say that the object is accelerating because there is a change in velocity, because change in direction. By the formula you can write A is equal to V minus U upon T, where V is final velocity, U is initial velocity and T is time taken. Or you can write delta V upon delta T instead of V minus U upon T. Delta V means change in velocity, delta T means change in time or time taken. I have 3 cases to help you understand the concept of acceleration. One is an object is moving 10 meters per second due east, then starts traveling 10 meters per second due north. As you can see that the magnitude is same, which means speed is same, but the direction has changed. It was traveling due east, now it is traveling due north. Due to change in direction, the object has different velocity now, and since the velocity has changed, I will say that the object is accelerating. 10 meters per second due east, 7 meters per second due east. As you can see that the velocity is changed not because of change in direction but because of change in speed. Because velocity is a vector quantity, it is dependent upon magnitude, it is dependent upon direction. So since the direction is not changed but the magnitude is changed, so the velocity is not same. Change in velocity is called acceleration. In the third case, 10 meters per second due east, 5 meters per second due south. Both of the magnitude and the direction is changed. It was traveling 10 meters per second due east, now it is traveling 5 meters per second due south. So velocity is not same. We can call it acceleration. SI unit for acceleration is meters per second upon second, because in numerator it's velocity, in denominator it is time, so meters per second upon second is actually meters per second square. But I will suggest you to read it as meters per second. It will help you understand the concept. If the acceleration of the object is 5 meters per second square, I will read it as 5 meters per second every second, which means if at time 0 the speed of the object is 0, at time 1 the speed will be 5, at time 2 it will be 10, 3, 15, which means after every second the change in velocity of the object is actually 5 meters per second. 5 meters per second every second. As you can see, 5 in 1 second, 5 in the next second, and 5 in the next second. This is the concept of acceleration. And now we are moving on to note that acceleration of object, if object move with same speed and same direction, there will be no acceleration. But if the object has same speed but different directions, then there will be acceleration. Now we are moving on to VT graphs. The first graph is zero gradient. Gradient is 0, constant, non-zero, positive, constant, non-zero, negative, gradient is increasing because the line is not straight and it is becoming vertical, so gradient is increasing. The line is becoming horizontal, gradient is decreasing. The formula for gradient is y2 minus y1 upon x2 minus x1, but in this case we will apply v2 minus v1 upon t2 minus t1, which is actually acceleration. Now if the gradient is 0, which means acceleration is 0. If the gradient is 0, which means acceleration is 0. Now in these two cases, both graphs have 0 acceleration, but in graph number 1 the velocity is 0, but in graph number 2 the velocity is not 0 but constant, which means acceleration has two definitions. 0 acceleration has two definitions. If acceleration is 0, there can be two meanings. Either the object will be at rest or it is moving with a constant speed. In the third case, the acceleration is constant, which means the object is actually increasing its velocity or speed but with a uniform rate. As you can see in this example, after every 1 second the increase in speed is 5 meters per second. At 2 it's 10, at 3 it's 15. In example number 4, the gradient is negative because the value of y is constantly decreasing, but the line is straight, which means that this is uniform deceleration because the decrease in velocity is constant per unit time. In this case, the gradient is increasing, which means acceleration is increasing. In this case, the gradient is decreasing, which means acceleration is decreasing. Keep in mind that decrease in acceleration is not deceleration because the velocity. Keep in mind that the decrease in acceleration is not deceleration because the velocity is not decreasing. Velocity is increasing but with a decreasing rate. In this example, there are two velocities, positive and negative. This graph is for the object which is thrown upwards and the object then moves towards the ground, and the line is straight, which is actually showing that the acceleration is constant throughout the motion. whether it is upward motion or the downward motion. Positive velocity is moving away, negative velocity is velocity when the object is moving towards. Now, area under the graph. Area under VT graph is actually distance, or you can call it displacement as well. In this graph, from A to B, the object is accelerating. From B to C, the object is at constant speed but zero acceleration. From C to D, the object is actually decelerating with a uniform rate. Now, if I want to find out how much distance the object has traveled while it is moving from 0 seconds till 5 seconds, I will take area under graph, and this is actually triangle. So the area of triangle is half into base into height. So it will be half into 5 into 20, which is 50 meters. Similarly, if I want to find out how much distance the object has covered when it is moving at constant speed, so I will take area under BC, which is 5 to 15, which is 10 seconds multiplied by 20. So it will give you 200 meters. 15 till 17, which means 2 seconds, and 20. So half into 2 into 20 gives 20 meters. If I want to find out the complete distance traveled by the object in 17 seconds or in the complete journey, I will add these three distances, 50, 200 and 20, to find out the total distance traveled by the object. That's it for today's lecture. Sorry for making a long video.
Please subscribe to the channel to be updated. Thanks.